Welcome back. We're going to continue solving these more complex equations here. They're really not that complex. So I'm looking at this one here. I'm going from 0 to 360, not including 360. Most of the time we don't include 360 because sometimes that overlaps with 0 as well. If they do include 360, put a little square bracket here, and you get an answer of 0, then 360 is also an answer. And they could try to trick you like that. I'm not going to try to trick you like that. It seems kind of mean to do that. So usually if it's 0, I'm not going to say it's also 360 at the same time. So in this case, because there's only one trig ratio, cosecant, I'm just going to rearrange this. I'm going to add the 6 over, divide by 3, and I get 2. Now it's okay that the cosecant is 2, because I'm not going to take the cosecant inverse of 2. I'm going to replace cosecant with sine theta first. Rearrange for sine theta and get a half, and that's fine. Sine theta is a half. Okay. Then I do my reference angle calculation here. Get 30 degrees. Sometimes you don't even have to do that because you're like, oh, sine a half or sine theta is equal to a half. That's got to be 30 degrees. You should be getting pretty comfortable with the halves at least. Where's sine positive? Well, first, it's in the first quadrant, so there's 30 degrees there. And in the add sugar, second quadrant here. Right? Add sugar to coffee in my casserole. Okay, we're within a circle. So first quadrant and second quadrant are valid here. So we can have 30 degrees and 150 degrees would work here. Now, it's kind of tricky to verify this. You do have to replace the sine or the cosecant with 1 over sine. So technically it would be 3 divided by sine 30 minus 6 equals 0. Yeah, that works because 3 divided by sine 30 is 6. And then 3 divided by sine 150 would also be 6. Divided by, minus 6 is 0. So these are my two answers here. It's in degrees. These are in degrees, so we're all good here. I'm just going to box around that. So here I'm going to replace, I'm going to put a little let statement here, let x be sine theta. I'm just going to do that just to make this a little bit easier on myself. I'm doing this in radians from negative 180 to 360, including 180 and to 360. I guess that's more than a whole circle. There, it's like 1.5 circles or so. Let's rearrange this. I'm going to minus the 3x over to this side, so we get 2x, minus the 2 over there, get minus 1. X is equal to negative a half. What's a half? Again, this is good. Replace the sign with, replace the x with the signs again. Theta, ref, I'm not going to do the math on this because it's the same as the previous question. I get 30 degrees, but this time sine is negative, so it's in the bottom 2 quadrants. Add sugar to coffee, so it can't be in the top 2 quadrants. Both 30 degrees, and I need to find the standard position angles. So 180 plus 30 is 210, and then 160 minus 30 is 330. Heads in the way. Okay, now you can verify this. 5 times sine 210 plus 2, that's negative 0.5, and then 1 plus 3 times sine 210, negative half. So that works. Looks pretty good. Oh, not pretty good because I need to go a little bit more. There's more answers here too, right? Wrong. Okay, so I'm going to have to look at some coterminal angles and see whether or not they fit within this domain. So these two angles are within the first circle, but I can go backwards here. So what I'm going to do, because any coterminal angle will work mathematically, but does it fit in our domain? So I'm going to take 210 plus. I also have to change these into radians. We're forgetting about that. If I go 210 minus 360, I get a negative 150, which is within my domain. It's not quite negative 180, so it's just there. If I go 330 minus 360. I get negative 30 as well. Yep. The reason I'm minusing because I had to go back to the negative part of the circle. So you can see that there are going to be two more answers here. If I go from here back, so there's one, and then to here as well. So negative 180 would be right about here. So there's two answers backwards as well. So there's technically four answers to this question. What I'm going to have to do now is I'm going to have to change all of those into radians. So I'm going to divide them all by 180. Math, or enter. So I get, everything's going to be divided over 6 here. So I get 7 pi over 6. We did this one before, didn't we? This would be 11 pi over 6. Yeah, 11 pi over 6. Negative 150 divided by 180. Negative 5 pi over 6. And negative pi over 6. So there are all my answers for this one. It's good that I caught myself before. I think I was moving my head. I noticed, oh yeah, I got to do more. Sometimes they throw that at you to make these questions a little bit trickier. Sometimes. Maybe I'll do that too. Cool. Okay. Obviously, I don't think I gave you enough space to do these next few questions here, but they're the same, so hopefully you tried them out as well. Here's cotangents. I'm going to say cotangent. Let x be cotangent theta. I don't know what just happened there. Okay. And we're just going to solve this. So it's x squared plus x is equal to 0. This is a bit easier. It's just factor the x out. 0 and negative 1. So I have two cotangents I got to solve for here. So I have to solve for, come on. Programmer's glitching out here a little bit. Just 1 second. Yeah, it's kind of glitching out. Okay. So I have cotangent theta is equal to 0 and cotangent theta is equal to negative 1. So I have these two solutions I have to do here. The top one here, if I try to solve for tan, what happens? We get 1 over 0 undefined. So I can't do that one. And I also have tan theta. Well, actually, I can do that one. It is an answer. Sorry, I'll come back to that one in a bit. And negative 1. Okay. This would be 1 over, negative 1 over negative 1. So I can flip that over. So this will just be negative 1 again. Okay. So tan inverse of negative 1 is, tan inverse of 1 is 45 degrees. Tan is negative. I'll come back to that top one in a bit here. Tan is negative in these two quadrants, this second quadrant and the fourth quadrant. Tan inverse of 1 is 45 degrees. I'm going to deal with this radian part later. 45. So right now I have theta is equal to 135. That's 180 minus that, and then 315. And 315 is beyond my domain. My domain goes up to 180. So I have 135. 135 is one of my answers. Now this undefined one up here, this is the undefined part. It's still solvable even though I'm not allowed to divide by 0. You do have to remember what tan represents. Tan represents y over x. So this is when my x values are equal to 0. So on my circle, when is my x value equal to 0? Well, it's equal to 0 up here and down here, but it's when tan is equal to a positive number. Yeah, so it's going to be up here at the top one and not the bottom one. Because down here, this would be a negative 1 on the other side. So this is, actually, it doesn't really matter because it's plus 1 and negative 1, but let's just go with this top one here. I'm not going to do the bottom one because the circle doesn't go that far. So here, all the way around to here. So those could be my two answers. So 90 or 270. Now you can type in your calculator. You can go tan 90 and you get undefined, and you also go tan 270 in your calculator. I get a domain error in my calculator when I do that. So they both give me this undefined answer, but 1 over an undefined is 0. So even though I get an undefined answer over here, cotangent of that undefined is a 0. So it still works. It's just kind of a weird mathematical anomaly. So we're going to cross out the 270 because that is outside my domain. So my two answers are 90 and 135. Yeah, so now you run into a problem here where you can't verify these answers. You could verify them by graphing them, right? You could try to graph them and try to figure out is 90 and 135, are they, do they work? But you also run into a problem trying to verify this because you want to do the 1 over, and you get some problems when you try to do that in your calculator. I believe I could do that on Desmos. Let's just see. Yeah, so I just wanted to show you this in Desmos. So I typed these two things in my calculator. Nope, I want to do this. It's a bit trickier to do, but cotangent inverse of 0 is 90 degrees. I changed my Desmos to degree mode down here. So that does work. Technically, you can just type these into your calculator and you could solve this. You could verify to see if this works. You could do this for any one of these and just verify to see if they work. Or just solve them because I can't see what you're really doing. It'd be nice if we tried to do these algebraically. I'm going to type this one into my calculator here. So cotangent squared theta. So in Desmos, under functions is where you would find cotangent. Cotangent x. I'm going to put the square on the outside here. Plus cot x. And what was the next one here? It's going to be equal to 0. I want to graph this. I'm going to make y is equal to. I think that should work out. Let me just double check. There's my graphs. This is a very strange looking graph, isn't it? It's because of the square and all the non-permissible values. Like cot to 0 is undefined. So you square an undefined number, doesn't work. Okay. So I'm going to put in y is equal to 0. And you can see that it crosses the 0 a few times here. So it's equal to 0. That's why I put another line here. So it crosses at a few different answers here. All right, 90, 135 are the two answers that we had. All right. You could also have negative 45, negative 90. There's the 270 we had before that I crossed off. There's the 315 over here that I crossed off because that's beyond my domain, right? So they are there, but they're just beyond our domain. So we don't have these. All right, and there's a good verification tool just to see if you did it correct. Put that over there. Okay. Last little bit here, because I didn't put a box around these yet, but this is pi over 2, and this is going to be over 4. I think it's 3 pi over 4. You just double check that. 135 divided by 180. Math, enter. 3/4, yeah. Cool, and there's my answer. Okay, so let's try this next one here, and then maybe we'll pause and have another part 3 video for this one. We have to figure out how we're going to space these videos out. Hopefully I've done that already. So let cos theta is equal to x. So here's 2x squared plus 3x plus 1. Another complex trinomial. It's 2x, 2x. What multiplies out to? So that's a 2 and a 1. It's going to multiply up to 2 and add to 3, so 2 and 1. But this one here reduces. This one does not. So I have two answers of -1 and -1/2. Okay. Now, yeah, I did not give you guys enough space at all to do this. So I'm just going to write that over here. So our first one here is going to be cos theta is equal to -1. Then I also have cos theta is equal to -1/2. I've got to solve for both of those. To solve this one, if you take the cos inverse of 1, you're going to realize you get 0 degrees, because this is when my x value, when is my x value equal to -1? It is equal to -1 in one spot and one spot only, over here. So my theta is 180 degrees. Okay, that's within my domain. So that's good so far, because it's 0 to 360. Then over here, cos is equal to -1/2. So using the cast rule, negative, cos is negative in this quadrant, this quadrant. My reference angle, 60 degrees. I need those two, so this would be a 120. Let me just verify that. I just want to quickly do that too. Yeah, -1/2 and 240. Cool. Those are within my domain as well. So I have 3 answers for this question. So I have 120, 180, and 240. Okay. Then we're going to quickly change these into radians, because that's what the question says up there. So it's right in here. It's got to be in rads. So I have 2 pi over 3. I have pi, which is good. That's an easy one. And why did I go 360? And 4 pi over 3. Perfect. And there you go. Pretty nice answers. I think I'll pause this video, give you another, or stop this video, and then the last video we'll do the last 3 questions here. I think that's it. And then that'll end off the first chapter of Trig, and then we'll have a little test, and we'll move on after that to talk about trig functions and graphs. I'll see you in the next video.